Okay, so simultaneous equations. So far we've only solved equations with one variable. So for example, we've solved things like this, where even though we have more than one term maybe, there's only one variable. We're going to solve equations now with two variables to start with, and that means that you're actually going to have to solve two equations at the same time, and that's why this is called simultaneous equations, and you can also call this a system of equations. Generally speaking, if you have two variables, like we have here, a y and an x, then we should have at least two equations. So if we have three variables, we probably need three equations. There are different ways of solving these. The first one that I'll show you is substitution. And substitution, for a lot of you guys, means to plug something in. And that's really all we're going to do here. Here it tells you that y is worth 2x plus 1. So instead of writing 5 minus y, you could write 5 minus 2x plus 1. And by plugging in, or by substituting, you now end up with something that only has one variable. Now it is on both sides, so we do have to solve it, but this you guys have done in the past. So distribute the negative. Everything with a variable I'm going to bring to the right side by adding 2x. And then this one I'm going to add over here so that I get, what do I get? 5 plus 2 is 7. Those cancel. Minus 1 is equal to 4x plus 2x is 6x. So if 6 is equal to 6x, then x equals 1. Okay, don't stop there, because keep in mind that I started out by saying we have two variables. So we do need to solve two variables for both of the variables. If you have x is 1 though, and you know that y is equal to 2x plus 1, then now you can plug the value of 1 into here. So you can write y equals 2 times 1 plus 1, and 2 times 1 is 2, plus 1 is 3, and usually the solution here is given as a coordinate, so you could write the solution is 1, 3. Different example, same method, both of these say y equals. Well, if 3x minus 4 equals y, and y also equals a negative x plus 12, then these two things have to be equal. So this one you can just equate them to each other, which in essence is that you either plug 3x minus 4 in here, or you plugged in a negative x plus 12 in over there. Add x on both sides, because I prefer to work with positive x's, so I'm going to add x. And then here, plus 4 and plus 4. So we would get 4x equals, that cancels, make sure I'm doing this right, 16 divided by 4, so x will equal 4, and then again plug in the x to figure out what your y is, so 3 times 4 minus 4, 12 minus 4 equals 8. Okay, so here the solution should be 4, 8. Sometimes students ask, does it matter where you plug it in? It shouldn't. So if I plug in the 4 in the second one, I should still get 8. And you see that it does work either way. Okay, so that's called substitution. Elimination is another way that you can solve these. So with elimination, you are going to try to cancel out. So to eliminate, so you like to cancel one variable. Okay. So here, if I look at these equations, and the cancelling is done usually by adding or subtracting. So if I look at these two equations, and if I say, well, let's add and see what happens. So 4x plus 3x is 7x, and a negative y plus y is 0. So by adding the two equations, you get 5 plus 9 equals 14. You get an equation with only one variable. And in this case, that's super easy to solve. So x is 2. Keep in mind that only gives you one of the values. You now need to make sure you get the next value. And on this one it takes a little bit more work because the x and the y happen to be on the same side. So I get 8 minus y is equal to 5, so y should be 3. So the solution set here is 2, 3. Okay, that worked great because I set that up so we could just add or subtract. So, if we look at these and we're going to either add or subtract, so let's see, 2 plus 3 is 5, so I get 5x plus 5y. Well, that's not helping me. I didn't eliminate any. Well, you can also try subtraction. So instead of saying plus, you could say minus. And 2x minus 3x is a negative x, and 3 minus 2 is a negative y. So that didn't help me either. So sometimes you actually have to create coefficients, so are the values for the x and the y's. You have to create coefficients that are equal. So if I'm looking to, for example, I want to eliminate the x's now because I eliminated the y's here. So 2x and 3x, the smallest number they have in common is 6. So if I can make those both say 6, which you can, so if I do 3 times the top one, then make sure you do 3 times all of these parts. So 3 times 2, that's the 6 that I'm sort of after, that's 6x, and 3 times 3 is 9y, and 3 times 8 is 24. And then in the bottom equation, I'm going to multiply by 2. 2 times 3 is 6x, 2 times 2 is 4y, and 2 times 2 is 4. And then now, adding doesn't work, but 6 minus 6 does work. So if I'm just going to subtract here, 6 minus 6 is 0, 9 minus 4 is 5y, and 24 minus 4 is 20. So, and 20 divided by 5 is 4. So y equals 4. Plug that one in either of these two equations. So we'll pick the bottom one for this one, just to, again, illustrate it doesn't matter which one you use. And I shouldn't talk and write at the same time. So 2 times 4 is what I needed here. I already wrote down the 8. So that gives you an 8. Subtract 8 on both sides. So you get a negative 6 divided by 3. So x equals a negative 2. When you write the solution out, make sure you write a negative 2, 4. Because this is written, again, like a coordinate point. This is an x and a y value. And usually we write the x's first. Alright. Well, I just referenced coordinate points. So let's look at that last one, the 2x plus 3y equals 8 and 3x plus 2y equals 2. And let's put it on a coordinate grid, because that would be the third way that you can solve them. So you can graph these. Now solving it graphically really is only a good solution in word problems. It's often handy, or if these numbers come out nice and even, which you don't really know until you know what the solution is. So, but I do want you to understand that this can be done graphically, because a lot of times we give you graphs and then from the graph you make some inferences. So now the question is, how do I graph these things? So let's start with the first one. Okay, so there are different ways of graphing this. You can plug in zeros for the x's and the y's, and that would be using intercepts. So if I say, well, let's see what happens when x is 0, then you get 0 plus 3y equals 8. So then you get 3y equals 8, so y equals 8 over 3. So that means that the point 0, 8 over 3 is on my first line. So that's on line 1. You could also then use a y value of 0. That one works out a little bit better. So 2x plus 0 equals 8. So that means that 2x is 8. So that is the case when x is 4. So that point is 4, 0. So that would be one way to do it. So 1, 2, 3, 4. I get a dot there. And then 0, 8 over 3. And then, so here's the problem a little bit. 8 over 3 is just under 3. So that's over here. So that's not really a very accurate point. Okay? So let's see if I can go a straight line. So it looks a little like this. Okay. Let's look at the second one. So the second one, what if I try to graph 3x plus 2y equals 2? Alright, so I'm going to graph this one differently. Some of you prefer the y equals mx plus b format. So if you move the 3x to the other side first, then it says 2y equals a negative 3x plus 2. And then if you divide by 2 on all of these spots, you get the equation in the format that you guys are probably most familiar with, or some of you are most familiar with. And that would be a negative 3 over 2 x plus 1, and then you graph it based on there. So some of you would then be plugging in values, like what happens when you plug in a 0, you're at 1. Probably don't want to plug in a 1 because then I have a fraction, so maybe if I plugged in a 2, then I would get a negative 3 over 2 times 2 plus 1. So at 2 I get a negative 3 plus 1, that's a negative 2. So I could use those dots. So at 2 I get a negative 2. At 0 I get 1. And then those two will create a dot, create a line. Oh, that's not good at all. And then apparently my intersection is over here. And if I did my markings right, that should be at a negative 2 and 4. Okay, so graphically it would look like this. Okay, thanks.